Simplifying exponents. When multiplying like bases, we can add the exponents a plus b. When dividing like bases, we can subtract the exponents a minus b. Having a power raised to a power, we can multiply exponents a times b. If you have a negative exponent, we can take the reciprocal of the term and make the exponent positive. And last four definitions. If you have two terms inside the parentheses, similar to distributive property, we can give each term the exponent. If you have a fraction inside the parentheses, we can give each number of the fraction, numerator and denominator, the same exponent. If you have a fraction to a negative power, we can first take the reciprocal of that fraction, and then with the power outside, we can give to both numerator and denominator. And last definition, any number, any term to the zero power is equal to 1. Title of the first section today is Simplify Exponents. First problem, the first parentheses, 1/3, a to the 8th power, and b to the 2nd power, times a second parentheses, 2, a to the 2nd power, and b to the 2nd power. Simplifying, we can combine both of these terms together. Looking first at the coefficients, we have 1/3 and 2. We can multiply coefficients or multiply the numbers. 1/3 times 2. If you want to make the 2 a fraction, 2/1, multiplying the denominator and the numerator, we'll have 2/3. Combining the a exponents, we have a to the 8th times a to the 2nd. When we're multiplying like exponents or like terms, the exponents we can add together. A to the 8th times a to the 2nd would be a to the 10th power. And b to the 2nd power times b to the 2nd power. Again, we can add exponents when we have a like base. That would be b to the 4th power. So the answer to the first question would be 2/3, a to the 10th, b to the 4th. Second question, and last question for the section. -12, m to the 4th power, and n to the 8th power, times, in parentheses, m to the 3rd power, times n to the 2nd power, all divided by 36, m to the 3rd power, times n. Simplifying this expression, we can first combine like terms on the numerator, leaving the coefficient -12 for right now. We have m to the 4th times m to the 3rd. Again, like bases, we can add the exponents, which will give us m to the 7th, and n to the 8th times n squared. Adding the exponents again, we'll have n to the 10th power. All divided by, leaving the denominator the same, 36, m to the 3rd power times n. Simplifying from here, we can reduce fractions. We have -12 over 36. Reducing fractions, we can divide each of these by 12. So we'll have -1 in the numerator and 3 in the denominator. Dividing fractions, if we have the same base, both m's, looking back at the formulas, we can subtract exponents. 7 minus 3 will give us m to the 4th power. And subtracting the n exponents, n to the 10th divided by n, or we can make it n to the 1st power. 10 minus 1 will give us n to the 9th. So our final answer, -1, m to the 4th, n to the 9th, over 3. Title of the last section today is Simplify more exponents. In this section, we'll continue to simplify exponents using the exponent properties. First question, 30, a to the negative 2 power, b to the negative 6 power, all divided by 60, a to the negative 6 power, and b to the negative 8 power. Simplifying exponents. One of the first steps we can do to get rid of negative exponents is to take the reciprocal of each one. The coefficients 30 and 60 do not have negative exponents, so 30 would remain the same and 60 would remain the same. If we have a to the power of negative 2, if it's a negative 2 in the numerator, we can rewrite that a to the positive 2 in the denominator. And likewise, if we have a to the negative 6 in the denominator, we can rewrite that in the numerator, changing the exponent to a positive 6. Also with the b's, b to the negative 6, we can write in the denominator as b to the positive 6, and b to the negative 8, we can write in the numerator as b to the positive 8. Simplifying from here, the coefficients 30 and 60, we can reduce or divide those. Dividing each one by 30, we'll be left with 1 over 2. Exponents again, when we divide the like terms, the exponents we can subtract. 6 minus 2 would be a to the 4th. And subtracting the b exponents, 8 minus 6 would be b to the 2nd power. So our final answer would be a to the 4th, b squared, divided by 2. Second question, and last question for the section. Inside parentheses, we have 4x to the negative 3rd power times y to the 2nd power divided by x, y to the negative 5th power. And outside parentheses, raised to the power of negative 2. One way to start this question, the exponent outside negative 2 goes to each number and each term inside the parentheses. We have 4 to the negative 2 power, which would be 4 to the negative 2. Taking the negative 2 to the x power, having a power to a power, looking back at our rules, we'll multiply exponents. Negative 3 times negative 2, that would be x to the positive 6. And continuing the numerator, we'll have the exponent of 2 raised to the power of negative 2, or 2 times negative 2 would be y to the negative 4. For the denominator, each question will get a power of negative 2. If there's no exponent on the x, we can put a 1. So we'll have 1 times negative 2, or we'll have x to the negative 2 power. And for the y term, negative 5 times negative 2 would be y to the positive 10th power. Simplifying from here, any negative exponents, we can change those around by taking the reciprocal or switching the spots on the fraction. If we have 4 to the negative 2 in the numerator, we can rewrite that as 4 to the positive 2 in the denominator. X to the 6 would stay the same since it's positive. Y to the negative 4, we can move that to the denominator and change it y to the positive 4. X to the negative 2 in the denominator, we can switch that to the numerator and make it x to the positive 2. And y to the positive 10 would stay the same in the denominator. And last step, combining like terms. X to the 6 times x squared. If we have the same base, we can add the exponents, which would be x to the 8th over 4 squared would be 4 times 4, 16. And y to the 4th times y to the 10th, the same base again, we can add the exponents, which would be y to the 14th. So our final answer, x to the 8th over 16 times y to the 14th.